Okay, gang, I'm going to just do a second example of this just to make sure we're all on the same page for our first exam. I'll do the technique of finding the vertex both ways again. I'll probably be able to move through this a little quicker because I don't have to do an intro again, okay? So I'm going to go right to finding the vertex by completing the square, so you can see that one more time if that interests you. So you literally just push the constant over to the side. That's the first step. The second step is that you have to make the leading coefficient a positive 1. And again, whatever you take off, whatever you divide off the front term, whatever you factor off the front term, you have to factor off the second term as well. So because I'm factoring out a -1 from both these terms, it makes this guy negative, right? Because if I distributed this back in, it would give me back this. All right, so now I'm good to put in that third term to calculate it. So how you calculate it, again, you use the completing the square formula, which is 1/2 b squared. The b value is in front of the linear term. You don't have to include what's out here. It's just what's right here. So it's a -6. B in this case is a -6. Half of -6 is -3. -3 squared is 9. So that means that I need to add a 9 here. Now this is again the part where it gets really tricky because this 9 is being multiplied by a -1, which means that what I really put in there was a -9. What I really put in here was a -9. So to counterbalance that, to make it go to 0, so that I didn't change the problem at all, I didn't change the weight of it, I then have to add 9 so that it balances out to 0. So like if I multiplied everything out and combined all like terms, I'd be back at the original. That's what I mean by that. Okay, so now the next step here is to factor this. This is called a perfect square of difference. Perfect square of difference. Again, do not write it like neighbors. Write it quantity squared, like a photocopy, so that it looks like it's in vertex form. All right, so the vertex of this guy is going to be opposite of the inside, always opposite of the inside, same sign as the outside. So this graph is pushed to the right and up. Okay, push to the right and up, and this negative is making it reflect over the x-axis. So it's upside down, it's frowning. This graph is having a rough morning, okay? It's frowning. Let me do it by the formula for those of you who would like to see that one more time. So the vertex formula, and again, A is the coefficient of the quadratic term. It's never part of the variable, it's just the number. B is the coefficient of the linear term. Make sure you always include the plus or minus when you grab A and B. Okay, so I'm going to put in my A and my B. Again, there's a negative in the formula. We've got a double negative here, so it's canceling to a positive. And as I said last time, this is a spot where students tend to not be sure what to do next. So even though we're calculating HK, H is a special X and Y, K is a special Y. So we're going to actually plug X in to find Y. So here we go. I'm going to plug 3 into the original. So this is getting exciting. We're already almost at the end of the first week, and since this course is very short, that's quite significant. So good job, gang. We're getting there, and we're getting there pretty fast. 10, 1. Okay. All right, so as you can see, and as we expect, the vertex is the vertex is the same. It just depends what tool you want to use to get there. All right, I'd also like to graph this for people who would like to see another example of a parabola being graphed at the level, you know, these are at the level of the exam. Where's my factored form? I like it in both. Well, I guess it doesn't matter. This one looks like it's going to factor. Okay, so, well, you know, I need the vertex of it. So where did I write it? Okay, so we said 3, 1. Okay. All right, gang. All right, let's see what we got here. Vertex is 3, 1. Right here. Let's do the y-intercept. All right, I gotta need the sharpening. Okay, y-intercept, can do it off of either of these. This is the easiest one to see when your x's go away. Okay, like we said, this guy had the negative out front, which means he's face down. I'm going to ask you to do a point by symmetry off of this, right? Remember how to do this? The axis of symmetry cuts through the center. So the axis of symmetry is x equals to 3 if you draw, if you say it as a line. And we are 3 units away from the axis of symmetry, so our buddy is always equal in distance on the other side, the same amount, right? So I have to walk over a total of 6 units, and it's always at the same height. All right, let's do the x-intercepts on this one. You can see it's going to cross them. Okay, so we're going to set this equal to 0. Now you don't want to factor with a lead negative, so you can either multiply by -1 to everybody, or you can factor out the -1. It's just up to you. I'll probably just factor it out, because then some people wonder, like, well, where'd it go? Like, but it's not, you can divide it off. You can make it go away. All right, now I'm factoring. And when I set this equal to 0, this x would have to be 2, and this x would have to be 4, if you set each piece equal to 0. So you've got 2, 0 as one x-intercept, and you've got 4, 0 as the other. Okay, of course I have to look at the time as I make the movie. We're at 9. Okay, something's off here. Where did I make a boo-boo? 1, 2, 3, 4. And I'm sure you guys noticed that, and we're saying, Professor Whelan, that point needs to move over. Okay, there we go. I get this guy, did I count him? Okay. 1, 2, 3, 4, 5, 6. I did. Good. Okay, voila, there's that beauty. Beautiful looking parabola. All right, gang, that's it for this section. I'm gonna move us on to 2.2 next. Catch you. Bye-bye.